Okay, today we're going to talk about multiplying and factoring polynomials. So, Chapter 7, Section 3 is actually pretty intense in terms of the amount of material that gets covered in 7.3. So, we'll spend 3 days on this. So the first day is fairly straightforward. It's a lot of stuff you've seen and then some new stuff. So the first thing says multiply these two binomials by whichever method you choose. So you could FOIL, use the box method, whatever. I will use the box method, and you can choose whichever method you like. Okay, so we'll write 3x minus 5 and 2x plus 7 on this side. So then we do 2x times 3x, that's 6x squared. Negative 5 times 2x is negative 10x. 3x times 7 is 21x. And 7 times negative 5 is negative 35. So when we combine like terms, we get 6x squared plus 11x minus 35. So nothing new. We've done lots of multiplying binomials together before. It's fairly straightforward so far. So when you multiply these two, you get that. So my next question is, what are the factors of 6x squared plus 11x minus 35? So hopefully you know that right off the bat, because we multiplied 3x minus 5 and 2x plus 7 together. So the factors of this are the two things we multiplied together to get it. So the factors of 6x squared plus 11x minus 35 are 3x minus 5 and 2x plus 7. Okay, and we've talked about this in the past. Okay, so this is a little bit new. We may have done some of these before. If we want to multiply 3 binomials together, we're going to start by multiplying the first two together, and then we'll talk about what to do with that answer. So we'll start with the first two. I wrote x minus 4 on top, and then 3x plus 2 on the side. And so to multiply these, 3x times x is 3x squared. Negative 4 times 3x is negative 12x. And then x times 2 is 2x. And then negative 4 times 2 is negative 8. So this would be 3x squared minus 10x minus 8. Okay, but that's just these two things multiplied together. So now we have to take that answer and multiply it by x minus 6. So we'll do that, and I've set up another box with the answer we got, so 3x squared minus 10x minus 8, and then x plus 6 along the top. And you can do this with the FOIL method as well. It's not really first, outer, inner, last anymore. What you'd do is you would multiply this by x plus 6, and then you just distribute each term to both in the second set of parentheses. I like this box method because it kind of organizes things for me. So this would be 3x to the third. So it would be 18x squared. So it would be negative 10x squared. Negative 60x. Negative 8x. And negative 48. So the nice thing is the like terms are on the diagonal here. So I'll connect those with a red line. So we get 3x squared, or sorry, 3x to the third for our answer, plus 8x squared, minus 68x, minus 48. Okay, so multiplying 3 binomials together, it's just a multi-step process. You do the first two, then you multiply that answer by the last one. Okay, so then my next question is, what are the factors of 3x to the third plus 8x squared minus 68x minus 48? Well, this is exactly what we just got for our answer, so the factors are those 3 things that we multiplied together to get it. So x minus 4, 3x plus 2, and x plus 6. So those are the factors. The next question then is, what are the zeros of that? So if you remember from when we talked about quadratics, the zeros are where it crosses the x-axis. So where would this cross the x-axis? Well, we set each of these factors equal to 0, and then we solve and get our answers for x. So what would make this part 0? That would be 4, because 4 minus 4 is 0. What would make this part 0? That would be negative 2/3, because 3 times negative 2/3 is negative 2, plus 2 is 0. And what would make this part 0? That would be negative 6. So our three zeros are 4, negative 2/3, and negative 6. So a way to check and make sure that you did this right is plug it into your calculator. Go to y equals, type it into y equals, and then look at the graph, and it should cross at 4, negative 2/3, and negative 6. And I can check. I do not have the graphing calculator app on my computer, but I can go to Wolfram Alpha and take a look at that. So let's do that real quick. Uh-oh. There we go. And I need to make this an exponent. And make this an exponent. And so if I look at the graph, it says, it's supposed to cross at, let's go back to our notes here, at negative 6, 4, negative 2/3. And so, I'm sorry, I said that wrong. Negative 6, 4, and negative 2/3. So we look at our graph, it crosses at 4, it crosses at negative 6, and then I believe this is negative 2 here. So this would be negative 1, so negative 2/3 is a little bit less than negative 1. So that looks right. Okay. So I want to make sure we understand that the factors are what you multiply to get to that polynomial, and that also gives you the zeros. Okay, a couple other ways to factor things. And so we've talked about factoring a lot, especially with just a quadratic. But there's some other special types of factoring. One is if you have two cube numbers that are added together, so the sum of two cubes. And this is just a formula you're going to have to get familiar with. And so the example I have is x to the third plus 27. Well, in this case, instead of a to the third, it's x to the third. So x will be a. And instead of b to the third, I have 27. Well, 27 is 3 to the third. Oops. So it would be 3 to the third. So in this case, b is 3. So what I'll do is I'll write a equals x, and b equals 3. And so wherever we see an a and b here, we just replace those with x and 3. So a is x, b is 3. So x plus 3, this would be x squared minus 3x plus 3 squared, which is 9. So the factors of x to the third plus 27 are x plus 3 and x squared minus 3x plus 9. So hopefully you realize that if we multiplied this times this, we would get x to the third plus 27. So these are the factors, which means if you multiply them together, you get that. Okay, there's also difference of two cubes, where instead of adding, we're subtracting in the middle. So it's just a different formula. It's very similar. The only thing that changes, instead of a plus b, it's a minus b. And instead of a minus, you get a plus here. So in this case, we have a to the third, and here we have 8a to the third. So in this case, a is actually, I don't like this. Let's change this to a b instead. No, not a b. I don't want to use a's and a's. Let's change it to, just call it 8x to the third. So in this case, we've got a equaling, well, we have to do the third root of this stuff to get us a. So it'd be 2x. And then the third root of 64 is 4, so b equals 4. Okay, so we'd have 2x minus 4. And then we have a squared, so that'd be 4x squared plus a times b, so 2x times 4 is 8x. And then b squared, so that'd be plus 16. Alright, so the factors of 8x to the third are, I'm going to get rid of this so we're not confused by that, are, sorry, 8x to the third minus 64 are 2x minus 4 and 4x squared plus 8x plus 16. Now this could have been factored a little bit further. I could factor out a 2 out of this, so it would be x minus 2. And I could have factored out a 4 out of this, so I'll do times 4 out in front, which would have been x squared plus 2x plus 4. So the answer completely factored is 8. X minus 2, x squared plus 2x plus 4. Okay. If you leave it like this, I'll be fine with that. That's okay. But if it says factor, you should probably continue it out until it's fully factored. Okay, last idea for the day then. We're factoring by grouping. And so this one, it's a little bit different. So what we're going to do is we're really just going to group the first two terms and then group the last two terms. And so what could we pull out of the first two terms? Well, it has an x squared in common, so we'll pull out an x squared, and what's left is x minus 5. And then what we can pull out of here is a negative 4. So we'll do minus 4, and then what's left over, if we divide by negative 4, we get just x. And this would be minus 5. And the cool thing is these have, both of them have x minus 5s, and so when we factor out an x minus 5 out of both of these terms, we're left with x squared minus 4. So the factors of this thing are these two terms. Now actually this could be factored further, so the answer would really be x minus 5, and then this factors into x plus 2, x minus 2. Okay, so those are our three factors. Now typically you're not going to come into something that gets factored further, but if it does, then you will factor it even further. Okay, so if you want some practice on your own, pause the video and try this one on your own right now. Otherwise, just follow along. So I'll start by grouping these two. So what's in common, I could pull out a 2 and I could pull out an x squared. So what's left here is just going to be an x, and then what's left here is a plus 3. And then I'm going to group these last two, and there's a 6 that's in common, so I'll go plus 6. And then what's left over is x plus 3 again. And so the only way this factoring by grouping will work is if you end up with like an x plus 3 and an x plus 3, or an x minus 5 and x minus 5, if you have the same term once you pull out the common factors here. So we get 2x squared plus 6, and then x plus 3. So we basically pulled out the x plus 3 out of both. What's left is 2x squared plus 6, and then the x plus 3. Okay? And then this you could pull out a 2 as well. So it'd be x squared plus 3, and then x plus 3. And that's as far as we can go. So that's it for today. Tomorrow we'll look at more stuff from section 7.3, and your assignment is here on page 445.